Hello and welcome to day 4, which is section 5, Trapezoids and Kites. So today we're going to talk about all those properties of trapezoids and kites. We're going to use those properties to find missing side and angle measures. Just so you know, today is going to be a little bit of a longer video because there are so many properties of trapezoids and kites. So first thing, a trapezoid. Here's an example. A trapezoid is a quadrilateral. So it has 4 sides. Exactly one pair of sides are parallel. So in this figure, TR and PA are parallel. The other sides are not parallel. So TP and RA are not parallel. If there's only one pair of parallel sides, we know that a trapezoid is not a parallelogram. It's completely separate from a parallelogram. So this would be important to write down on your property sheet. The different parts that you need to know. Again, here's our trapezoid. These two sides, the sides that are parallel, are called the bases. The sides that are not parallel are called the legs. So parallel sides are bases, non-parallel sides are legs. Now for the angles. These two angles are called the base angles. T and R are also the base angles. That's because T and R rest on the same base. They rest on base TR. So some important properties. The consecutive non-base angles are supplementary. Consecutive non-base angles are supplementary. And that's pretty much it. So here's that figure that we had before. Okay, so we know that P and A are base angles. So when it says non-base angles, it means P and T are supplementary. And then A and R are supplementary. So that would be important to write down. Angle P and angle T are supplementary. And then angle R and angle A are supplementary. Remember from before that supplementary means they sum to be 180 degrees. And that's honestly all that's important about a trapezoid. Consecutive non-base angles are supplementary, and then also that there's one pair of parallel sides. Okay, moving on. There's also something called an isosceles trapezoid. So here's an example. Okay, what do you notice is different from before? Hopefully you notice those red tick marks. An isosceles trapezoid is a trapezoid, so it has all the same properties of a trapezoid. One pair of parallel sides, consecutive non-base angles are supplementary, but the legs are congruent. So FR and OG are the bases, because they're the ones that are parallel. FG and RO are the legs. They're going to be congruent. So some important properties. Congruent base angles. So if we mark that on our figure, G is one base angle. O is its partner in crime because they're on the same base, GO. Those are going to be congruent. Then we have F and R, partners in crime. They're on base FR, so they are congruent. Second important property is that the diagonals are congruent. This is only true in an isosceles trapezoid. So it's only true in a trapezoid where the legs are congruent. Okay, something else. Midsegments. A midsegment is a trapezoid connects the midpoints of the legs. So it connects the midpoints of the legs. So let's draw an example. So this only applies to a trapezoid. Okay, now let's remember a trapezoid means that one pair of sides are parallel. So I have a trapezoid. It connects the midpoints of the legs. So these two are the legs. Here's one midpoint. Here's another midpoint. So that right there is called the midsegment. It's important that you have this in your notes, and it's important that you have a drawing. So please make sure you have this drawing in your notes. Now we don't just talk about this for no reason. The midsegment does have an important property. It's parallel to the bases, and its length is equal to the average of the lengths of the bases. Okay, so while you're writing that down, I'm going to redraw that figure that we had. Okay, so here I labeled ME as our midsegment. So ME is the midsegment of trapezoid ABCD. Okay, so it's parallel to the bases. So the first thing, ME, is going to be parallel. And remember, the bases are the ones that are parallel themselves. So AB and DC. ME is going to be parallel to AB. It's also going to be parallel to DC. And its length is equal to the average of the lengths of the bases. So ME's length is equal to the average of the other two bases. Average means add them up. So I'm going to add AB and DC, and then I'm going to divide by 2. So those are the two important properties. So moving on to our first example. How long is segment TS? Okay, so this has to do with midsegments, as you probably have guessed. I know that this is a midsegment because I have a midpoint here. I also have a midpoint here. Okay, we are looking for segment TS. I'm going to mark that as X since we don't know what it is. Now we know that the midsegment is equal to the average of the other two bases. Our midsegment is 38.5. That's equal to the average of the bases. So remember, that means add up the bases and divide by 2. Okay, now I can do 38.5 over 1 and use cross products. 38.5 multiplied by 2, 77. That's going to be equal to 26 add X. Now if I subtract 26, I get 51 is equal to X. So in our figure, TS is 51 units long. Okay, moving forward. The answer is 51, like I just told you. Okay, that was trapezoids and kite. That was trapezoids, not kites yet. I know we didn't get too much practice in the video, but we will get some practice when you come to class. Now a kite is something completely different properties. So try to wipe away the trapezoid mind and think just in the mind of a kite. Okay, I have a little riddle for you. You throw away the outside and cook the inside. Then you eat the outside and throw away the inside. What did you eat? Okay, kite definition. Here's an example of a kite. A kite is a quadrilateral, so it has 4 sides. 2 pairs of consecutive congruent sides, but the opposite sides are not congruent. So we got to think consecutive congruent sides. Consecutive just means they're next to each other. So in our figure, KI and KE are congruent. So KI and KE are consecutive congruent sides. And then I have IT is consecutive and congruent with TE. But the opposite sides are not congruent. Because it says that the opposite sides are not congruent, we know that a kite cannot be a parallelogram. Because a parallelogram, the opposite sides are always congruent. So a kite is completely different from a trapezoid. It's completely different from a parallelogram. So make sure you get this down in your notebook and on your property sheet. Okay, properties. Kite has a lot of important properties. Diagonals are perpendicular. So the diagonals form a right angle. That should remind you of a rhombus and a square. Also, 1 pair of opposite angles are congruent. 1 pair of opposite angles are congruent. And then 1 diagonal is the perpendicular bisector of the other. So here's the figure. I'm going to mark some stuff on it. 1 pair of opposite angles are congruent. So in this case, it's angle I is congruent to angle E. It's always the angle between the sides that are not congruent. So KE is not congruent to ET, therefore we pick that angle. KI is not congruent to IT, so we pick angle I, which is in between. So angles I and E are congruent. One diagonal is the perpendicular bisector of the other. So we know that they're perpendicular, but one diagonal bisects the other. In this case, this is the diagonal that's bisected. Okay, so make sure you get all of those down, both on your formula sheet or your property sheet and then in your notes. We have two examples to do. Here's our first example. It says, what is the perimeter of kite RATS? Okay, so we are told RT is 24. So if RT is 24, remember that one diagonal bisects the other. It's clear that SA is not bisected. The two parts are different. They're 20 and 12. Okay, that means RT is bisected. If RT is 24, this little part is 12, and this little part is 12. Now, we need to find the perimeter, so we need all the sides. We need RA, AT, TS, RS. I'm going to start by finding RA. Hopefully you notice we have two sides that are 12 and 12, so we can do the Pythagorean theorem, or this is a 45, 45, 90 triangle. So we have L, L, L root 2. We know the sides across from the 45 are 12 and 12. So the diagonal is going to be 12 root 2. So in this case, this side is 12 root 2, and this side is 12 root 2. If you did not notice that right away, that's okay. If you do Pythagorean theorem, you're still going to get 12 root 2. Now I need to know this side here. There's no trick here. We have to do the Pythagorean theorem. So I have 20 squared add 12 squared is equal to y squared. 20 squared is 400. 12 squared is 144. It's equal to y squared. So I end up with 544 is equal to y squared. Take the square root. We need to simplify the square root of 544. Now, I would expect that you cannot do this off the top of your head, which is fine. 544 is even, so as I said before, I would always try 4. Okay, 544 is 4 multiplied by root 136. Now I would see if 136 is divisible by 4. It is. It's root 4 and root 34. Okay, now this root 4 gives us a 2. This root 4 gives us another 2. Root 34 we cannot simplify. So this becomes 4 root 34. Having a little bit of difficulty, so if you could please mark that on your figure, and I'll mark it when the pen starts working again. Okay, so I have 4 root 34. And I have 4 root 34. Now last step, find the perimeter. That means add up the sides. So I have 4 root 34. Add 4 root 34. Add 12 root 2. Add 12 root 2. These are like terms. They become 8 root 34. These are like terms. They become 24 root 2. So the number under the root stays the way that it is. We can't add these two because they have different numbers under the root. So that is our perimeter. 8 root 34, add 24 root 2. If you find the decimal, this ends up to be about 80.6. So that was a review of 45, 45, 90, Pythagorean theorem, simplifying radicals. So all that stuff that we did in the last chapter, again, is coming up. Okay, we have one last example. Okay, how big are angles U and S? Pause the video right now, try it on your own, come back when you are finished, please. Okay, we know in a kite, one pair of the opposite angles are congruent. Here it's clear that B and G are not congruent, they're different angles. That means U and S have to be congruent. So I'm going to mark them both X. Now, every quadrilateral, the angles add up to 360 degrees. So I have 62, add 132, add 2x. This is equal to 360 degrees. When I add these two, I get 194 is equal to, plus 2x is equal to 360. Subtracting 194, I get 2x is equal to 166. Divided by 2, x equals 83 degrees. So here, angles U and S are both 83 degrees. Okay, that was just going to tell us our answer is 83 and 83. Look back at what we did. We did properties of trapezoids and kites to find missing angles and side measures. I know we didn't get too many examples in, but we will do some more examples in class. Last thing that you need to do is go on to Schoology and take this Day 4 quiz, this one here. This is due Friday before class. It's only 3 problems. It's a little bit of review, and then there's one question on kites or trapezoids. I don't remember which one. But please make sure you take that before class and that you have your property card filled out. And I will see you when you get to class. Good luck. Bye.